Hello everyone, my name is Angela Brown and I will be presenting and discussing my Lab 1 report from Physics 2212. The lab encompasses an experiment using charged pieces of tape and other neutral household items. The overall purpose of the lab is to use charged pieces of tape to see how objects with different or the same charge interact, calculate the charge through observing the connection between forces, and approximating excess charge. The presentation includes my results, observations, calculations, code, and the final concept questions. Here are some of the principles I used throughout the lab. Let's introduce the overall experiment and steps. The steps of the lab are to create two charged U-tapes by sticking a tape on top of a flat surface as a base tape and sticking the U-tape on top of the base tape. After ripping the U-tape off, it is charged and ready for the experiment. I assumed that the two U-tapes would repel each other due to the fact that they were produced using the same base tape. I tested and observed that the tapes did repel each other, indicating they were the same charge. I observed when putting my hand and other neutral objects near the tapes, it was attracted because no matter the charge of the tape, it would polarize the neutral objects. The lab continued with me negatively charging a pin by rubbing it into my hair. I used the pin to discover the charge of the U-tapes, and since they were attracted, I knew the tapes are positively charged. Finally, using the two U-tapes, I was able to observe one tape floating the other through the power of repulsion. I suspended one piece of tape onto two books and moved the other tape under the suspended tape until the tape was floated. The large picture to the right is an image of how the U-tape interacted with the pen to give you a visual of the physical experiment. Using the floating half of the experiment, I was asked to figure out the net force on the floating tape and the forces within the net force. The lab told you that the momentum of the floating tape was constant, so using the momentum principle, I concluded that the net force was zero due to no acceleration. The two forces acting on the floating tape are the electric force of tape A, the non-floating tape, on tape B, the floating tape. For the net force to be zero, we know that the two forces have equal magnitude but are opposite in direction due to Newton's third law, as shown in the free body diagram to the right. The next aspect of the lab involved using measurements taken throughout the experiment and the assumptions and concepts stated in the last slide. To find the gravitational force acting on tape B, the mass was required. The area of tape B was 0.2 meters, and using the conversion given in the lab of 1 meter equaling 1 gram, I was able to compute the mass. The equation for the force of gravity is the mass found previously times the constant g. We established earlier that the force of gravity and the electric force on tape B were equal in opposite directions, so we can set the electric force to the negative of gravitational force. The electric force equation used is the point charge equation times the charge, and we set that equal to mg. We assume that the charge on both tapes are the same. After rearranging the equation, I was able to calculate the charge. The next set of calculations were focused on the atoms and the ratios on the tape. To calculate the number of electrons, I took the previously found charge and divided it by the charge of one electron. I used the value of electron deficiency based on the approximation of the cross-sectional area of an atom that has an approximate radius of 1 times 10 to the negative 10th. I found the area of the tape and divided it by the area of an atom, which was calculated by multiplying the radius by 2 and squaring it. The ratio of electrons to atoms was found by dividing the number of electrons by the number of atoms. The assumption needed for these calculations was the charge of the tape was distributed evenly over the tape surface. The coding part of the lab in GlowScript was used to create a visual of the free body diagram and calculate the charge, electric fields, electric forces, and the gravitational force. I produced two different programs due to the confusion on the instructions of how to produce the calculations. The green ball is tape B, the blue ball is tape A, the yellow arrows is gravitational force, the red arrow is electric force from the other tape, and for tape A, the red arrow is overlapped under the yellow arrow. These colors are for both versions. My first version did not use the charge I calculated in the experiment portion of the lab. I calculated the gravitational force and then used the same equation in the experiment to find the charge, since all the assumptions bled over into the code, which are that the pieces of tape are uniformly charged, air resistance can be neglected, and the tapes can be represented as point charges. I used the charge to calculate the electric field of both tapes and the electric forces on each tape. My second version included the charge calculated in the experimental portion. I used the function to calculate an electric field from lab 0 to create both electric fields of both tapes. After finding the electric fields, I found the force acting on both tapes and calculated the gravitational force as well. Here are my answers to the final concept questions.